Hello, everybody. I'm Angelo Zinzi from the Italian Space Agency and the Space Science Data Center. And I'm talking today about our efforts in order to make the LICIACube data available on the MATISSE web tool of the ASDC. First of all, I would like to talk you about the LICIACube mission. Okay, LICIACube is a mission encompassing a large effort from the Italian community. Is coordinated by ASI with the scientific coordination by INAF, and the LICIACube has been assembled by Argotech. Of course, we are part of a very large team, and the LICIACube has been the very first Italian deep space mission. Okay, the CubeSat is built as followed, so is a 6U CubeSat equipped with two different imaging instruments, in particular Leia and Luke. Leia is a catadioptric camera with a nominal resolution at the closest approach of 1.38 meter per pixel, whereas Luke is a camera able of acquiring RGB images and therefore very useful for surface characterization, for example. This is the cruise of DART and LICIACube spacecraft. The launch has been on November 24, 2021, from the Vandenberg Space Force base in California, whereas the impact has been performed on September 26, 2022. LICIACube has been released by DART 15 days before the impact in order to perform this autonomous closest approach to acquire images at very close distance from Dimorphos. Dimorphos is the target of the DART spacecraft and is a secondary asteroid of the Didymos asteroid. Didymos is a more or less 780 meters asteroid, whereas Dimorphos has more or less 160 meters. The mission of LICIACube, as I already explained, was to being carried by DART until some days before the DART Dimorphos impact, and then after this release, LICIACube became an autonomous spacecraft. We performed two different orbital maneuvers, and after that, in the very proximity of the closest approach, LICIACube was able to autonomously adjust its attitude in order to perform this flyby at more or less 7 kilometers per second with respect to Dimorphos, always taking the target inside the field of view. For what regard the SOC, ASDC is responsible for the LICIACube data management through the Scientific Operations Center. The data came directly from LICIACube to the antennas of the DSN. Then these data were transferred to the Mission Control Center by Argotech, and we at ASDC received the raw data and transformed them to fit standard, and therefore we calibrated this data, releasing them prior to the team, and now the data are available to the public from different sites, from different sources. This is the very first telemetry received by LICIACube as soon as it has been released by DART. As I already said before, LICIACube was the first Italian deep space mission, and it is also to be it is also worth it to say that it has been the very first CubeSat flybying an asteroid, a double asteroid system. These are two images acquired by LICIACube just before the closest approach on the left and just after the closest approach on the right. We can see Didymos as the bigger object inside the images, Dimorphos as the small object in the bottom of these images, with the plume that is seen from a front side view before the closest approach, and in another geometry in the image on the right. The SOC activities was devoted in particular to attach a series of data products to the website of LICIACube SOC. As I already said, we managed the connection between SOC and the MCC, but after this phase, we took care of the LICIACube data in order to preserve their long-standing information, so that we formatted the data sets compliant to the PDS4 formats, and then we ingested this data inside MATISSE. We had a paper about this work published 2 years ago on the Planetary Science Journal, and all the details of this work can be found in that paper. For what regards data format activities, we defined the data product format for images and XML labels in order to be PDS compliant, PS4 compliant. We use some Python packages in order to do that, and also in order to make all the pipeline automatic, so that the data has been directly converted to the FITS format useful for the PDS4 directly as they were downloaded to the Earth. On the last December, so more or less 1 month ago, the raw and calibrated datasets from both Leia and Luke have been certified PDS4 compliant and published on the PDS small body nodes, so that it is now completely public for everybody. After that, we thought to use MATISSE in order to have advanced visualization of LICIACube data. We did this for the Luke datasets looking at Dimorphos, because only in that case we have the adequate resolution in order to be shown on MATISSE. MATISSE is the ASDC web tool for the exploration, for the planetary exploration data sets, and can be reached at the URL shown here. So from MATISSE, you can select the Didymos target, the LICIACube spacecraft, and the Leia instrument, and then you can have all the data displayed. You can also have a geographic query inside this dataset, and when you have the result table, you can select one observation. You can select one of the 3 different channels of the Luke camera, because Luke, as already said, is an RGB camera. And when this has been done, you can have the final visualization. Here you can see the 2D and the 3D visualization of MATISSE of LICIACube data. On the right, we can see the image directly projected over the Dimorphos 3D shape model, whereas on the left, we can see the FITS projection of the same data. Even if the FITS 2D projection can seem not so useful, however, it is important, this data, because if you download the FITS and you explode it inside Python, so you can, of course, have a very useful projection of the data, also because you can add the different observation of Leia, of Luke, of Didymos, so that you can add them, you can have mosaics, and you can merge all the data you want. Of course, you have to take care about the observation geometry, about the illumination conditions, and so on. But after this modification, you can, of course, compare different observation of Luke, of Dimorphos, and understand how it changed along the time. Okay, this is all for me. Thank you for your attention, and I'm, of course, ready to answer your question. You can reach me at this email. Thank you. Bye.